We have seen parity error correction, error detection rather. This video we will have a look at Hamming error correction code, where more than one correction bits are used. Or so the way it is done, if there is a formula how many bits are needed. So if we have something like this, the formula goes 2 to the power k. So L is the number of data bits, k is the number of bits, parity bits. So we will need more than one. So let's say L is 4. We are doing for a 4-bit data. So we will see that L has to be k minus 1. So k has to be, if we do k is equal to 1, we will end up 2 minus 1, so that will be 0. If k is 2, we will have 4 minus 1 minus 4 minus 2, minus 1, which is 1. If k is 3, we will have 8 minus 3 minus 1, which is 4. So this is working. So we will need at least 3 bits for this correction. For correction of 4 bits, if data bits are 4, we will need 3 parity bits. Now let's see how the bits are assigned and how the total message is sent. So we will have 7-bit message. 4 of them are data bits and 3 are parity bits. So let's first say 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. We have 7 here. 1, 2, 3, 4, 5, 6, 7. Now these ones, wherever there is only one word, we will assign them as parity bits. So this one, and this one will be parity bits. So P1, P2 and P3, and the other ones will be the data bits. So this will be D1, D2, D3, D4. So this is our 7 bits, and this is how the the full 7 bits go. Parity bit, data bit, parity bit, data bit, data bit, data bit. So this one is 32. And this is how it goes. Now let's see how they check the parities. So this one, there is a 1 here, so it will check parity with wherever there is 1 in the database in this one. So this one and this one and this one. So P1, D1, D2, D4. P1 will form parity with these 3. Then P2 has a 1 in the middle, so this one will go with P2 will go essentially with D1 because there is a 1 in the middle. D3 has a 1 in the middle and D4 has a 1 in the middle, so these 4. And then finally P3, it will go with P3 has a 1 in the beginning, so it will go with D2, which has a 1 in the beginning, means this bit, this position, so this position and this position. So this is how they will form parity. Let's see how they will form. So if we have a data, say 0, 1, 1, 1, and we want to form an even parity, that means the total number of ones has to be 0. Total number of ones has to be even, since it's even parity. So if that is the case, P1 will go with D1, D2, D3. So we can see that this is this is D1, this is D2, this is D3, this is D4. So D1, D2, D3, D1, D2, D4, D1, D2, D4. There are 2 ones already, so P1 will be 0. similarly there will be P2 here, this is P1, and there will be P3 here. P2 will go with D1, D3, D4. So that will go with D1, D3, D4, again 2 ones, so it will be 0 because the total number 1 is staying even. Final one P2 goes with P3, P3 is here, it goes with D2, D3, D4. So D2 is, there is a 1 here, there is a 1 here, there is a 1 here, 3 ones. So in order to make it even, so this will be the total, this will be the total 7 bits that will be transmitted. 3 parity bits P1, P2 and P3, 0, 0, 1 there, and this is the data 0, 1, 1. So this is how the Hamming code is formed. So I will show a few more examples maybe later and how the circuit is formed, but this video I don't want to make it very big, so I will finish here.